Okay, here we are, 1.6, and this is going to be the A video. As I look at the section here, it's a little bit long, so it's going to take a few videos to get through this, so sorry for that. All right, first of all, what we're going to do is we're going to look at factors, and if you remember right, the factors of a number are the numbers that you multiply together to get that number. So in this case, it's 3 times 7. In the case of 18, there are lots of different numbers. We've got 2 and 9, and 3 and 6. They're all factors. But one of the things that we went into are prime factors. What are the prime numbers that divide into 18? And that would be 2 times 3 times 3. Those three numbers, when you multiply them together, give you 18. These prime numbers, when you multiply them together, you get 21. So that brings us to the next part of this book, the greatest common factor. A greatest common factor is when you have several numbers and variables, and you are taking the biggest number that divides evenly into both of them. So, for instance, if I have 25 and 20, if I'm wanting the greatest common factor, I am looking for the biggest number that will go both into 25 and 20. And that greatest number is the number 5. 5 goes into 25, 5 goes into 20. That is the biggest number that goes into both of those. And in fact, with the 25, it's the only one. But if we had something like 20 and 30, the biggest number that goes into both of those, in fact, if we were to write these, the greatest number is going to be a 5 goes into it and a 4 does, and a 30, a 6 goes into it and a 5. Are there any other bigger numbers that go into 30? Yeah, 15 and 2. So that's a big number there, but 15 does not go into 20. So we can't use that one. We have to find one that is common to both the 20 and the 30 that is the biggest one, and in this case it's the number 5. So let's look at the very first example they give, bottom of page 68. They give us 25 x to the 5th plus 20 x to the 4th minus 30x cubed. All right, so first thing we're going to do when we're looking at finding the greatest common factor of all three of these is we look at the numbers first. What is the biggest number that goes into 25, 20, and 30? So in this case, it's 5. 5 goes into 25, goes into 20, and it goes into 30. Okay, there are bigger numbers that go into 20. 10 goes into 20, and 15 goes into 20 or 30. 10 also goes into 30, but so 10 goes into 20, 10 goes into 30, but it does not go into 25, so that doesn't count. So you have to work and try to figure out which is the biggest number that goes into all three of these, and in this case, it's 5. Then we look at the variable, x to the 5th, x to the 4th, x to the 3rd. Which variable and which exponent, obviously the only variable is x, but out of all the x's, which has the biggest exponent that goes into all three of these? So 5 is the biggest exponent, but this is a 4, so that doesn't work because 5 is bigger than 4 and 3 at the same time. So the biggest exponent that goes into all three of these is the 3. So one of the things to keep in mind when you're looking at exponents on variables, the smallest one will end up going into all three of them and happen to be the biggest one that goes into all three of these. So how many x cubed is the greatest common variable? So 5x cubed is the greatest common factor, the biggest number letter with an exponent that goes into each of these three terms. Now the next part is writing in parentheses what you have left. So if we pull a 5 out, 5 goes into 25 5 times. So we have 5 left, because if we multiply these two together, we get our 25 back, and that has to be the case. We took 3 of the possible 5 here, which means we have 2 left. We took 5 out of the 20, meaning we have 4 left. 4 times 5 is 20. We're dividing, okay? We're not just taking 5 out with 15 left over. We're saying how many 5s are in 20? 4. 5 goes into 20 4 times. X cubed goes into x to the 4th 1 time with 1 left over. We took out 3 and we have 1. And here, 5 goes into 30 6 times. X cubed, we took out all of them, so we don't have a variable here. So here is the greatest common factor, and this ends up being what's left over here. So when I ask you to factor, that's what I'm asking you to do. Take out the largest numbers and letters and exponents and whatever you can out of here and show me what's left. All right, so let's look at example 1. So we have 8 x. Oh, I'm just going to do x. Sometimes my A's look like 9s. Okay. The biggest number that goes into 8 is 8. The biggest number that goes into this 8 is 8. And the biggest number that goes into 48 is 8. So that was pretty easy to figure that out. So I'm going to pull an 8 out. I'm going to make a parenthesis. Then I'm going to look and say, oops, I'm sorry, I left these as A's, and they needed to make them X's. What is the largest X that I can pull out? Now remember what I said. The largest X I can pull out is always the one with the least number on the exponent. So this 1 here is the only one we can pull out, which leaves me with stuff inside of here. So what's that stuff look like? Pulled an 8 out. 8 goes into 8 1 time. X goes into x cubed, x squared. So really when you're doing the variables with the exponents, you just look and say, okay, pulled 1 out, I have 2 left over. I pulled 1 out, I've got 1 left over. And over here, I pulled 1 out and I have none left over. So do you see where this 8 goes into 8 1 time, 8 goes into 8 1 time, which I guess I could put a 1 there. And then I've got 8 goes into 48 6 times. So my final answer is 8x times the quantity. I don't really need the 1s there. I can just leave those as x squared minus x and call that good. So I factored out an 8x. So let's look at one that's a little more complicated here. 5x squared times a plus b minus 6x times the quantity a plus b minus 7 times the quantity a plus b. All right, so when you look at these, let's see what we've got. If I am looking at the greatest common factor of this, so I've got a 5, I got a 6, and I've got a negative 7. There is no number that goes into all 3 of these. 5 goes into 5, but it doesn't go into 6 or 7. 6 has 3 and 2, doesn't work for either one of those. 7 is a prime number, it doesn't go into either one of those because it's larger. So what about x's? I have an x squared there, an x there, but I don't have an x over here. So x isn't common to either one of them. The only thing that's common is an a plus b, an a plus b, and an a plus b. So I'm going to factor out an a plus b, and I have left everything else. And that's all there is to that. I just look and see what's common to each one of these. Okay, and then I factored those out. All right, there's another situation that you'll run into, and that's when you have something like 5x plus 5y plus x squared plus xy. And this is called factoring by grouping, middle of page 69. Factoring by grouping means rearranging the factors in such a way that I have some things that are common to two of the factors. So like right here, I have a 5 common to here and here. Over here, I have an x common to here and here. I could rewrite this, and I'll do this in blue, as 5x plus x squared plus xy plus 5y. And then I've got a group here, and I've got a group here, because this has x's in it and this has y's. It doesn't matter how you group them. The only reason I'm leaving this as is because I don't have to rewrite anything. So let's put parentheses around the first two terms and the second two terms. What do I have common in that binomial? I have a 5, left with x plus y. What do I have common here? I've got an x, left with x plus y. Notice I have an x plus y there and an x plus y there. That's what I want to see happen. So I take the things that I pulled out of the parentheses, and in this case, my 5 and my x, and I put them together. I put a plus sign there because there's a plus sign there. I'm going to put them together because they're outside all alone. Then I take what's in parentheses and write it one time, and I'm done. If you use the FOIL method, you would end up getting this mess up here as an answer. So what we did is we simplified it. We made it simpler to work with. So example 3 gives us another chance to try this out. A squared b squared plus b squared plus 8a squared plus 8. So again, you can write these in any order you want, as long as you're trying to write them in an order that puts your pair together. So right here, we have two b's there. So I'm not going to split these up because I'd have to rewrite them. So if I look at this, I can bring out a b squared. I'm left with a, but this is the important part. I took this b away. Whenever you take the entire thing away, there's always a 1 left over. Don't forget to put the 1 in there. Okay, so what happens if I were to distribute this b squared times this? I'd get b squared times a. And, oops, I'm sorry, I left the squared off the a. I'd get a squared times b squared. B squared times 1 is b squared. So I get what I have back here again. If I can't get what I started with, then I did something wrong. So that's why the 1 is there, is so you can multiply it by something to get this b squared back. Okay, the second part, we're going to take out an 8, and we're left with a squared plus 1. These two will again be the same. We take what was in outside, put them together in parentheses, and we take our a squared plus 1, write it once, and there we go. Now what would happen if I were to take a squared b squared plus b squared plus 8, a squared plus 8, and I were to put them in a different order than I did over here? What would that look like? Well, let's try that. I'm going to rewrite it in blue. So let's go a squared b squared plus 8a squared plus b squared plus 8. Okay, look what happens here. I can take an a squared out of here and an a squared out of here. There's nothing I can take out of here. There's nothing that goes together with that. So therefore, when you start rearranging things, you've got to be careful, because in both of the groups, in both of the pairs of binomials, you need to be able to pull something out or it's not going to work. So I'm going to go ahead and stop with 1.6a and go over to 1.6b as we start factoring trinomials with leading coefficients of 1. Oh, God, that sounds exciting.